Hello, welcome back once again. Today we have this interesting equation. 2 to the power of x is equal to 4 times x. Our goal is to solve for the real values of x. So how can we solve this problem? Let us first make a general solution to this type of equations. Sometimes the equation may be 3 to the power of x is equal to 5 times x. Sometimes it may be 4 to the power of x is equal to 6 times x, and so on. So in general, we can say that a raised to the power of x is equal to b multiplied by x, where a and b are real numbers, right? Okay, so here is what we're going to do and how to solve this type of equations. We're going to divide both sides of this equation by a raised to the power of x multiplied by b. This side by a raised to the power of x multiplied by b. And if you notice here, you will see that there are some nice cancellations going on. This and this. From the right hand side, this and this. You get the idea? Okay, so next we have from the right hand side, we have x all over a raised to the power of x. That this is equal to, from the left hand side, we just have 1 over b. Remember, we're trying to solve for x. So here we can write this as x multiplied by 1 over a to the power of x is same as a raised to the power of negative x. So this is equal to 1 divided by b. What is next to do? Okay, so what we're going to do here is to actually rewrite a to the power of negative x. If you remember this idea that b can be rewritten as e raised to the power of ln of b, right? If b has a power of k, we can actually rewrite this as e raised to the power of k times the ln of b. So this part here, we can write that as e raised to the power of negative x multiplied by the ln of a. You get the idea? Then we have times x from here. This is equal to 1 divided by b. Next, our goal is to make sure that this power of e is equal with the coefficient or any expression by the side of e. So the only slight difference between these two is the negative sign and the natural log of a. So this will tell you that we need to multiply both sides by negative natural log of a. And by so doing, we have negative x times the natural log of a multiplied by e raised to the power of negative x times the natural log of a. So this will give us negative natural log of a divided by b. Now we can make use of the Lambert W function. Let us recall about this function. We know that this is the property of the Lambert W function. The Lambert W function of p times e raised to the power of p is equal to p. Take a look. The power of e here is equal with this expression at the side. And if you look at this here, this and this are equal. So we can make use of the Lambert W function from both sides. Cool. So the left hand side, without telling you, you know what that we evaluate to. That will give us negative x times the natural log of a. So the right hand side, we just have the w of the negative natural log of a divided by b. Divide both sides by the negative natural log of a, and we are done, right? Cool. Amazing, right? So this. So we have here x is equal to maintain a general solution, we're going to put a subscript n. This will be negative w with a subscript n here times the negative natural log of a divided by b, then all over the natural log of a. So the subscripts can be 0, it can be -1, it can be 1, it can be 2. So these are just the branch cuts, and most times the zeroth and the negative branch cuts always give us some real solutions. Others may give us complex solutions. Okay, so this is the general solution. Should we call it a formula? We can. So remember, the original equation is 2 raised to the power of x is equal to 4 raised to the power of x, or I mean 4 times x, sorry. So that is 4 times x, right? So this is 4 times x, and this solution here is for general. A raised to the power of x is equal to b times x. So if you compare these equations together now, you find out that a will be equal to 2 and b will be equal to 4. So that the solution to this equation now will be x is equal to -w with a subscript n of negative natural log of 2 all over 4, right? Then divided by natural log of a, which is natural log of 2. Now we're going to take n is equal to -1, and we're going to take n is equal to 0. So these two are the branch cuts that gives us the two real solutions to this problem, right? So our first solution, x is equal to -w with a subscript 0 of the negative natural log of 2 divided by 4 all over the natural log of 2. So this one here is approximately equal to 0.309 906 932 932 and then 38. Interesting, right? And for the branch cut here, the negative with the subscript -1 of the natural log of 2 divided by 4 all over the natural log of 2. This one here is exactly equal to 4. So these are the two real solutions. But let me tell you something you need to know or understand. If you want to check the input of this Lambert W function using the Wolfram alpha, I know most of us have the idea of the Wolfram alpha. I don't make use of Wolfram alpha when I want to evaluate the Lambert W function. I simply have a calculator which helps me to get the approximate values very nicely. So for you to get this in the Wolfram alpha, you can write as negative product logarithm. So this is same as product log in this way. Then you have to put the 0 here, then put a comma. So you don't need to make a subscript because Wolfram alpha may not understand what you are talking about. The negative natural log of 2, you will write it as -L, capital L, then n. Then you can put your 2 divided by 4, close that bracket. Then you can write divided by the ln of 2. The Wolfram alpha doesn't understand ln like this. Doesn't understand it. It rather understands like this. Okay, so this is how you can take the input in the Wolfram alpha. Thank you for watching. Please, if you really enjoy my videos, kindly subscribe to my channel. You can like, comment and share. You can share with your friends. Have a nice day.